Okay, so the very first group inside the SSS tab, we have our givens. AB is congruent to AC, mark it in the diagram. BY is congruent to CY, mark it in the diagram. And then my suggestion to you was to next list out all 5 methods that we have for proving triangles congruent. Now in this case, we know it's SSS because it's notes on SSS, but we won't always. So now we have to go through them one by one and see if they work. But I know right off the bat there's no right angle, so it's definitely not hypotenuse leg. I also know that they gave me 2 sides. Those both use 2 sides. This only uses 1 side. This only uses 1 side, so they are probably not the methods that I want. So now we have to decide, is it SSS or SAS? If it was SAS, we would have to know angle B is congruent to angle C. And we don't. To be SSS, we would have to know that AY is congruent to AY. Well, of course it is, it's the same segment. So we can get that piece, which makes this an SSS group. Now the plan. I know that it is an SSS group. My first pair of sides is AB congruent to AC. That was given. Then I had BY congruent to CY. Also given. Then I pulled in AY is congruent to AY. And I know that those match because of the reflexive property. So the plan is a nice little outline that helps keep me on track. And in a more complicated proof can help to ensure that you're not making mistakes. And also that you're not skipping steps. And for me, it helps stay organized. So now these 3 pieces of the plan are going to be my 3 main branches of the proof. Every triangle proof is going to have 3 main branches that lead into the congruent triangles. So our goal is to get something that looks like that. And we get there by attacking these 3 branches. So in this group, I should have a side, and a side, leading into those congruent triangles. The first side is AB congruent to AC, and I can actually start with that since it was given. You don't need anything to come above it. And now, that piece of my plan is done. That branch is done. My second branch, BY is congruent to CY, that also was given, so I can just write that in. And that branch is done. My third branch, AY is congruent to AY. Not given, but it was reflexive property, so there are no boxes that come above it. We can just write it down. And my 3 branches are complete, so I am ready to go to my triangles. Triangle BYA is congruent to triangle CYA, and my method is SSS congruent to SSS. In the future, your branches, each branch is probably going to have multiple steps, but this kind of gives us an idea of how to start a plan, how to write a plan, and how to organize the proof. In the branches, in the future, we might have to start to do a little bit more work, but stay organized, use your plan, and they really aren't that bad. Our second question, we have RQ is parallel to TS. First off, I'm looking at this picture and I see triangles, and they're asking me to prove triangles. And so anytime they're asking me to prove triangles, I know that I'm going to have to use one of these methods. Which means I need to be working with sides and angles, but they're giving me parallel lines. Why the heck could they be giving me parallel lines? Well, they're giving me parallel lines to lead me to some angles. What angles? So they're telling me that RQ is parallel to TS. We have all of our parallel line theorems, and they all deal with transversals. These parallels actually have 3 transversals. This transversal, not super useful to me. Neither is this one, because the angles these transversals give aren't in one triangle and then in the other. Whereas this transversal When we sketch this one in, it gives us that nice Z shape. And when we have that Z shape, we have alternate interior angles, which are helpful. So they gave us angles. And if we're going to refer to those angles, I'm going to put a 1 and a 2 in there. So it's easier to refer to them than using 3 letters. We also have given to us that RQ is congruent to TS. So right now I have one angle and one side given. They're not right triangles, so it's not HL. I have an angle, so it's not SSS. So now we have to decide which of these methods is it. If it were AAS, I would have to know that those angles match. And sometimes that is an error I see. Some people think that those angles come from the parallel lines. But does this angle touch this parallel line? It doesn't. It only goes part way. So we can't get those angles from the parallel lines, and we actually can't get those angles at all. So angle S is not an option. Or angle sine. ASA, we would have to know that these two angles match. We don't know that right now. So we don't think that one's an option. So let's go to our final choice and hope that that one works. SAS. To be SAS, we have a side, we have an angle, and we would need this side congruent to, well, itself. And it is, that's a good thing. Which means this is an SAS group. My first pair of sides was RQ congruent to TS, and that was given. My angle was angle 1 congruent to angle 2. And I knew that those were congruent because they are alternate interior angles. Then I have that RT is congruent to RT. And my reason here is reflexive property. We have a plan. So now we're ready to organize the group. 3 main branches. First branch starts with our side. RQ is congruent to TS. Well, it's given, so we just write it in. And once it's in the proof, cross it off, that branch is complete. We move to our second branch. In our second branch, we need angle 1 is congruent to angle 2. That wasn't given. So we have to think, how did we get there? Well, alternate interior angles got us there. Alternate interior angles come from parallel lines. And so the next thing I need to bring into the proof is the parallel lines. The parallel lines are what allowed me to mark in the diagram that angle 1 is congruent to angle 2. So as a proof, the parallel lines come before those angles. We can't just write alternate interior. We have to write out the full reason. If 2 parallel lines are cut by a transversal, alternate interior angles are congruent. Once we have that, we have our angles, we cross off our second branch. Third branch, we have to get RT congruent to RT. Well, that's simple, since it's reflexive property. Now, some of you might have noticed that I'm saying RT congruent to RT, when technically the corresponding sides are RT and TR. It actually might be nicer to say RT congruent to TR, so that you're naming them appropriately, but for sides, it is acceptable to just say RT congruent to RT. It's triangles where the order really starts to matter. Third branch done. If the third branch is done, that means I'm done. I have 3 branches. If I have 3 branches, I'm ready to wrap it up. Triangle QRT is congruent to triangle STR. And my reason is SAS congruent to SAS. Not so bad. 3 branches. Each branch, as we move on, is going to get a little bit larger, but the idea stays the same. Third tab, CPCTC. First, if you want to write this down, what CPCTC stands for is corresponding parts of congruent triangles are congruent. So it's just an acronym that we are allowed to write instead of writing out that full phrase. And we saw that phrase in lesson 6 yesterday. We are given G is the midpoint to EI and FH. So if G is the midpoint of EI, we know that those are congruent. If G is the midpoint of FH, we know that these are congruent to each other, not necessarily to the two previous segments. And that's all we have. So we go through our 5 methods. Well, it's not a right triangle, so that's not an option. And we're given 2 sides, so most likely it's going to be one of these. So we have to decide, can we get the other side, or can we get the other angle? Well, we can't get the other side. We don't have, it's not reflexive property, so we don't know it, which means we need to get that angle. And we can get that angle 1 is congruent to angle 2, because those are vertical angles, making this a side angle side group. My first pair of sides is EG congruent to IG. That comes from the fact that we have a midpoint. Then we have angle 1 congruent to angle 2. Those are vertical angles. Then we have that FG is congruent to HG. Also midpoint. Now some of you might be wondering, why the heck am I doing triangle stuff when this asks me to prove that these lines are parallel? Well, to get lines parallel, we need angles. And to get angles, we need to steal from triangles using corresponding parts of congruent triangles are congruent. This is the ticket to stealing pieces from congruent triangles. So first, our first goal is to prove that triangle EFG is congruent to triangle, and we have to make sure we name it correctly. EFG has to match IHG. If we can get this to happen, we're going to be able to steal what we need to get to these parallel lines. So to make that happen, we have to do our 3 main branches. So my first branch starts with the EG congruent to IG, which comes from midpoint. So we have that G is the midpoint of EI and FH. Now this is the proof where style is going to start to come in as a factor for some of you. Some of you, because it's SAS, you're going to really want a side and then an angle and then a side to make your proof all nice and pretty and organized. That isn't necessary. They don't have to be in that exact order as long as you have them all. And I'll show you, I'm not going to make mine organized, so you'll see what that looks like. This given told me that EG was congruent to IG. But it also told me a second fact. So I'm going to divide this box. It did also lead me to the conclusion that FG was congruent to HG. And they both have the same reason. So that's why they're in a shared box. And our reason is a midpoint divides a segment into 2 congruent segments. And in that, we've crossed off both of our sides. So now all I have left is to get my angles. Angle 1 is congruent to angle 2. And our reason here is if 2 angles are vertical angles, then they are congruent. Third piece of my plan is done. So I'm ready to be done. I have 1, 2, 3 branches. They might not be in SAS order, but that totally doesn't matter. I have them all, so I'm ready to say triangle EFG is congruent to triangle IHG. Now, you don't have to name them the exact same way as I did, as long as you have the corresponding points in the right order. This was an SAS proof, so my reason is SAS congruent to SAS. There's the hard part. Now we need to steal stuff. We need to steal stuff that will prove to me that these lines are parallel. For these lines to be parallel, there has to be a transversal. And we're looking for alternate interior angles, such as these. So if I knew that angle F was congruent to angle H, I would know that alternate interior angles are congruent, which tells me that the lines must be parallel. And I do know that angle F is congruent to angle H because those are corresponding points. And in this case, I am allowed to use a single letter, angle F congruent to angle H, because there are no other angles at those points. Now, if you wanted to put a 3 and a 4 in there, great. The reason those angles are congruent is because corresponding parts of congruent triangles are congruent, which is abbreviated as CPC-TC. So I got the angles. Now the angles lead me to the parallel lines. EF must be parallel to IH. And my reason is, if two lines are cut by a transversal, such that alternate interior angles are congruent and they are parallel. And that's what I was asked to prove, so I'm done. And it is very common to be asked to go beyond the congruent triangles and have to steal stuff. And so sometimes we steal stuff to prove the lines are parallel. Other times we might have to use parallel lines to get angles to help us prove the triangles, but parallel lines, they're not gone. They could be a part of this proof. Now I mentioned organization. Someone else, because they want their proof to look pretty and perfect, they might put here that G is the midpoint of EI. And that tells us that EG is congruent to IG. Great. Then they do their vertical angles. And then they write that G is the midpoint of FH. And that tells them that FG is congruent to HG, because they want that SAS pattern. Totally fine. Unnecessary, but if you like how it looks better, you can split that given up into those two branches to make it a little bit nicer to look at. And then the rest of the proof would be the same as the proof that I did in pink. So it's messy, but you could have it look a little bit different and still be correct.